Okay, everybody. Good morning, all of you. So today is a very interesting topic we have. In the previous classes, we have some elaborate concepts on functions, limit, continuity, differentiability. Now, if you are solving some problems on calculus, especially trigonometry, there will be some inverse concept. Already we have that concept with us. So the first question may be, when does the inverse exist? So if the function is 1, 1 and 1, 2, that is bijective, then we can find the inverse of that function, right? That is the meaning. So I will discuss that part also, how the trigonometric functions exist and what are the domain and ranges of that functions. So that is why now if I will define, initially I will define inverse function, inverse trigonometric functions. And inverse function exists if it is bijective, that we know from the previous classes. So basically I will discuss initially the definition or the concept of inverse trigonometry. So if x minus 1 less than equal to x less than equal to 1 be a real number and sin theta equal to x, if I write sin theta equal to x, then we may have infinitely many values of the angle theta which satisfy the equation sin theta equal to x. Let us try to understand this part. So if I draw the diagram of the sin x or sin theta, this is the wave type like structure, graph of the sine, and see you have, this is origin, this is pi by 2, this is pi, this is gonna be 3 pi by 2, 2 pi, etc. This side you have minus pi by 2, minus pi, minus 2 pi, etc. Okay. Now, suppose for example, I am taking the value, your x value is between minus 1 and 1. Because your range is minus 1 to 1. Range of sin theta cos theta is minus 1 to 1. That is why your x value is restricted within minus 1 and 1. So this is the range, right? Within this track, minus 1 and 1. That is why x values are minus 1 and 1. So suppose sin theta is x. Suppose for example, if I write x equal to half, that is sin theta equal to half. Can you tell me the value of theta? For what value of theta sin theta is half? For what value of theta sin theta is half? Any value, 30 degree, pi by 6. So it may be here, right? So let us draw a line sin theta equal to half. This is the half line. This is your half line, right? This is your half line. Now, how many values of theta? There are infinite, because you have pi by 6. Then you have this one, pi minus pi by 6, that is 5 pi by 6. Then you have this one, so on, 2 pi plus pi by 6. This side you have negative values. So there are infinite number of values of theta for which this equation sin theta is equal to half is satisfied. Am I clear, everyone? If I am clear?
Yes, sir.
Okay. So there are infinite number of values. So the language, once again, just look at the language. If x be a real number, so I have taken a real number half. Sin theta is equal to half is satisfied by infinite number of values. In this case, theta is represented as sin inverse x. How will you represent the angle theta? Theta is represented as sine inverse x. Sine theta is a real number because you are getting a particular value there. And these values which I was talking about, those values are basically the angle measurement. That's sine inverse x. So sine inverse x represents an angle, my dear. Inverse function, sine inverse, especially trigonometric inverse, is an angle. So sine inverse x represents an angle. And sine of this angle has the value x, right? So sine theta represents a pure number. So sine inverse x is a multiple valued function. Sine inverse x is a multiple valued function. Why? Because for y equal to x equal to half, you are having infinite number of values of the angle. So sine inverse x is a multiple valued function because we may have infinite many values of sine inverse x, and sine theta is a single valued function because for a particular value of theta you are having only one value. So sine theta is a single valued function, sine inverse x is a multiple valued function. Am I clear with this concept of the inverse? Multiple value, sine theta equal to x equal to suppose half. What is theta? So this is multiple value. Theta having infinite number of values for different values. But for a particular value of theta, you are getting only one value. So sine theta is a single value. But if you write theta equal to sine inverse x, it has infinite number of values. Clear once again? Now, so let me start with the graphs. So basically your sine graph, once again let me draw the sine graph. Is it 1 1 on 2? Is the graph 1 1 on 2 sin x? Is the graph of sin x is 1 1 on 2? Is this graph 1 1?
Many 1 on 2.
Yes, it is not 1 1. But yes, and on 2. Okay, into. But if you take a sectional part, if you take sectionally,
it will be bijective.
the portion of the graph, yes, then it will be 1 1 and 1 1 specially. So I will take the principal part. You can take this part, you can take this section, you can take the later section, or you can take the previous section, whatever be the section. So there are infinite number of branches you can take. But we will take this part that is near to origin. Your origin is here. Okay? So I will take this part, and this part is called the principal part or principal branch of the function. Especially the trigonometric functions. I will take the principal part, that is the near part, near the origin. So rest of the part I will remove. Otherwise the inverse function doesn't exist for the whole graph. That is why I have taken this part out. Okay? Am I clear? So this is the sin x. This is your sin x. This is your sin x. Now I will draw sin inverse x. So for this part you have inverse exist. So what is the domain of this part? What is the domain? minus pi by 2 to pi by 2, right? What is the range of this part? Minus 1 to 1. So let me write sin x. What is the domain? And what D for domain, R for range. So what is the domain of sin x? Because I have taken a principal part, so I will write the domain of the sin x is minus pi by 2 to pi by 2. Otherwise, I could have written minus infinity to plus infinity because the whole thing. But you cannot take the whole thing for the existence of inverse. Okay? Because sectionally you can take the function and the inverse exists. Otherwise, if you can take the whole thing, the inverse doesn't exist. So let me write, and this one is minus 1 to 1. Okay? Now, how to draw the inverse function? Let me draw first y equal to x line. This is your y equal to x line. And the inverse function is the reflection on this y equal to x line. If you want to draw the inverse function is basically the reflection on the curve. This is your inverse function. You see, this portion is your inverse function. This portion is your inverse function. This is your y equal to sin inverse x. It is nothing but the reflection on y equal to x. So if you have this portion, if you have take the reflection, that is, if you take this portion, you have a reflection this side. So this is your y equal to sin inverse x. Okay, and this is yours. So let me write sin inverse x. Now, what is the domain of sin inverse x? It will just switch.
Minus 1 to 1.
Yes. And this is minus pi by 2. Okay. So look at that. Your domain now, this portion. Okay. Let me remove this portion. Okay. Now I will consider this is your domain for sin inverse x. Look at that, domain is minus 1 to 1. And this is your range now. This is your pi by 2 and this is your minus. So look at that. This is the domain for sin inverse sin x and this is the domain for sin inverse x. Am I clear with sin inverse x? Now, let me draw cos inverse x. Similarly, I will take the principal branch of the graph. What is the principal branch of the graph? Let me draw the whole thing first. This is your cos x. This side also the same. What is the principal branch? You have to take the principal branch near the origin. So if you take 0 to pi, this function, this part is 1, 1 and 1. If you take 0 to pi, right? Okay. So let me remove this part. Okay. Pull. This pull curve, that is not 1, 1. Because if you draw horizontal line, that will cut at many points. That's many 1, not 1, 1. But if you, in this diagram, if you draw horizontal line, that will cut at exactly 1 point. So my intention is very clear. I have to make it 1, 1. Otherwise, you cannot draw one inverse function graph. Okay. Now, what is the next step? Your next step is to write y equal to x line. So let me write y equal to x line. Now, how to draw the inverse? Inverse is the reflection, mirror image. So I will draw the mirror image. Okay. So and this is your inverse function. Look at that, this portion has an image here and this portion has an image here. So this is your, this dotted one is your cos inverse x. Let me write here. What is the cos x domain? You have taken 0 to pi, right? And your range is as usual -1 to 1. So what is your cos inverse x? Cos inverse x is -1 to 1, and this gonna be 0 to pi. So your domain is again C. Your domain is confined between -1 and 1, and your range is 0 to pi. This one is your pi. Your range is 0 to pi. The expansion of the graph is 0 to pi, and the domain is this one. So that's true. Clear? So this is about sine inverse x and cos inverse x. Let me draw another important, that is tan inverse x. Steep form. Okay, this is your tan x. Tan x itself is 1 on 2, right? In -pi by 2 pi by 2. Okay, not required this one. This is your tan x. Okay, so it is 1 on 2 because you have taken the principal branch. This branch is the principal branch. No problem with that. Now I will draw y equal to x line. So what is your tan x? What is the domain? Open bracket. What is your range? Okay. So what is your tan inverse x should be? Got it? So let me draw the tan inverse x. It will be a image on the mirror y equal to x. So it will be like this. This dotted portion is your y equal to tan. Tan inverse x is an increasing function. Look at that. Tan inverse x is an increasing function. Got it? Okay. Let me draw cot inverse x also. Okay. Cos inverse x. Cos inverse x is decreasing. Okay. So what is your cot x? Cot x will be like this. Okay. And what about this point? This is to origin.
Pi by 2.
Pi by 2. This is y equal to x line. This dotted portion. Let me draw with the dot. Hey, this is your cot inverse. Cot inverse x is decreasing function. Domain and range. Domain is minus infinity to infinity, but range is 0 to pi. This is your pi. Okay, So that is about your graphing. Similarly, you can graph cosec inverse x, sec inverse x. Let me write the domain of that. Okay. Sec inverse x. Because sec pi by 2 is undefined. So the pi by 2 point is not there in the interval 0 to 5. Similarly, you can write cosec inverse x. You know that sec inverse sec x and cos x is greater or equal to 1. That means its value is less than equal to minus 1 and more than equal to 1. So it's sec inverse x and cosec inverse x domain will be this. And this is the range for sec inverse x, and you can write the domain for a range for minus pi by 2 to pi by 2, but 0 is excluded from that interval. Because it's inverse, each and every information is very important, especially the graphical concept. From the graphs, you can answer so many problems. Okay? Can I write this portion? Next is, I will write some properties on that. Suppose P1, that is property 1, that's especially on minus 6. I will write the minus 6. You see, I am writing sine inverse of minus 6 is minus sine inverse 6. Tan inverse of minus 6 is minus tan inverse 6. And cosec inverse of minus 6 is minus cosec inverse 6. Because these are all symmetry. Actually, sine inverse x, tan inverse x, and cosec inverse x are symmetric about the origin. Symmetric about the origin. So that is why this property. Symmetric about the, you check the graph of sine inverse x, tan inverse x, all are symmetric about the origin. Next property is, what about the others? Cos inverse minus x, pi minus cos inverse x, sec inverse minus x, pi minus sec inverse x, and cot inverse minus x, pi minus cot inverse x. What about their symmetric? They are symmetric about the point 0, pi. Just check the graph. Symmetric. That means cos inverse x, sec inverse x, and cot inverse x. Symmetric about the point 0, pi. Please check. Check the graph of cos inverse x. It's symmetric about the point 0, pi. 0, pi. This is the point 0, 1. That was the cos inverse x. Okay? And also 40 inverse x will be like this. All are symmetric. These functions are symmetric about 0, 1, so you have these relations. Property. Okay. Let me write P2, that is property 2. Property 2 is basically T of T inverse, that is outside the trigonometric function, inside the trigonometric function, that inverse. What happened with this? Number 1, sine of sine inverse x. How can you write? X. If very simple. Let theta equal to sine inverse x. X belongs to -1, 1 and theta belongs to -π/2, 5. Right? Is that clear? So I have written theta equal to sine inverse x. So which implies sine theta equal to x. If I write theta equal to sine inverse x belongs to this and theta belongs to this, then we have sine theta equal to x. So naturally, if you replace this theta by sine inverse x, you will get this relation. That's minus. Good. Very simple. My assumption is theta equal to sine inverse x. So sine theta equal to x. Again, I am replacing this theta by sine inverse x. So you have this relation. Okay, so very simple. So how will you draw that part? -1 to 1. Okay. This is -1. This is 1. This is your y equal to x. Actually, you are graphing this graph. Sine of sine inverse x is basically x, but it should be between -1 and 1. These two end of this graph, end points of these two graphs. This is your y equal to x. Next, similar relations, cos of cos inverse x, that is equal to x also, -1 less than equal to x less than equal to 1. Number 3, tan of tan inverse x, that is also x. X belongs to R. Cot of cot inverse x, that is equal to x. X belongs to R. Sec of sec inverse x equal to x. Mod x greater equal to 1. And number 6, cosec of cosec inverse x is also x. Mod x greater equal to 1. Sorry. So let me draw y equal to x. This graph is for tan of tan inverse x and cot of cot inverse x. The previous graph is same for cos inverse x also, y equal to x, the previous graph. And this one is cot of cot inverse x, tan of tan inverse x. Actually, it represents tan of tan inverse x equal to cot of cot inverse x equal to x, definitely, because and x belongs to R, so real number. That is why the arrow heads are at the terminus and the end points both. And you have sec of sec inverse x. This, let me draw this graph. This is your 1. This is your -1. Right? More than equal to 1. Mod x greater equal to 1. That means less than equal to -1. Y equal to x line, definitely it is y equal to x. It is more than equal to 1 and less than equal to -1. These both are for sec of sec inverse x equal to cosec of cosec inverse x. Am I clear? Is that clear? Graphing will make you more understandable. The things will be more clear on the graph. So this is about property 1, 2. Property 3, that will be on T inverse of T now. This is the most important part of trigonometry. Inverse trigonometry. Most important part. That is this will be x for all x belongs to -π/2 to π/2. Otherwise not. Let me write the intervals first. Cos inverse cos x is x, but it's restricted to 0 to pi. And tan inverse tan x for all x belongs to -π/2 to π/2. And cot inverse cot x is x for all x belongs to 0 to pi, and cosec inverse cosec x is equal to x for all x belongs to -π/2 to π/2 -0. Sec inverse of sec x is x for all x belongs to 0 to pi -π. But the thing is that this is fine. You have to remember this. Yes. Otherwise, you cannot write x. I will go to the problems and also analysis. Let me now draw the graph of sin inverse sin x. Before that, we have a very important question. If the x is not lying in the principal domain, what will happen? So for x not lying in the principal domain, not lying in the principal domain. So what will happen? So let me write y equal to sin inverse of sin x. That means sin y equal to sin x. So if y equal to sin x, sin y equal to sin x, that means for general values we can write y equal to n pi plus -1 whole to the power n into x. N belongs to the set of integers. But your y should be, please keep it in mind that y should be in this. because y is your bounded between -π/2 to π/2. You should keep it down. Okay, because you see now I will write some values. Okay, let me draw the graphs. N is an integer, plus minus 1, 0, plus minus 1, plus minus 2, etc. No, any kind of negative होते पारे, 0 होते पारे, any generally 0 no, generally 0. It can take negative value also. I am showing you the table. Can I have the upper part? Okay. I will draw the graphs on the upper part. Okay. Before that, value relation for this and range of it. So suppose you are substituting n is equal to -2. You have started. What is the value? Y equal to -2π plus x, right? And x belongs to, you write it, I'll write later on. N equal to -1, y equal to -5 minus x, right? N is equal to 0, y equal to x. N equal to 1, n equal to 1, it's pi minus x, right? N equal to 2, it will be y equal to 2π plus x, right? And so on. You have infinite number of x. And all, you see the relation, all are straight lines, right? All are straight lines, linear. So let me draw the graphs now. Let me draw in the middle. This is your y equal to x. See, when y equal to x, it's between -π/2 to π/2. So you have x belongs to -π/2 to π/2. Clear? It's from the analysis as well as from the graph. It's from the calculation as well as from the graph. Both are going on simultaneously. Next. All are straight lines. Look at that, your relations are all. So I'm just drawing the straight lines on the graph, plotting. So this is your pi/2 is gonna be pi. So this is your 3π/2. Okay. Now what is this? This is your y equal to pi minus x. See, where is your pi minus x? This one. Okay, and pi minus x is lies between π/2 to 3π/2. If you just remember the graph, nothing to carry on. Just remember the graph. Draw the graph within a second, few seconds, answer your question. Okay, so it is. So let me fill up this portion. X belongs to π/2 to 3π. Now, let me complete this part. This is your 2π. So this is your x minus 2π. Look at that. This is your x, y equal to x. So it's shifted 2π. So it is your x minus 2π. horizontal shifting of the graph. And this is between 3 pi by 2 and 5 pi by 2, right? This one. This one. I told you to fill up this one later on from the graph, so I will fill up from the graph. Clear? And if you plug these values here, the y values will be between minus pi by 2 to pi by 2. That's the purpose. This portion. Okay? And what about this one? Minus pi. So this is actually horizontal shifting of this graph. Minus pi minus x. Y equal to minus pi minus x. So this one, it's between minus pi. Minus pi and minus pi by 2, right? Minus 3 pi by 2, minus pi by 2, right? Minus 3 pi by 2, sorry. Yeah, that's right. So on. And the other portion. So you have, I think, this side, you have y equal to. That's it. Have you understood this portion? This is the most important concept. The first graph is important. First graph means sine inverse x, how to draw sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosec inverse x, sec inverse x. And the second important thing is this one, and the analysis also. Because of this, you have some mountain-like structures, and all are straight lines. And what is the range? Okay. So sine inverse of sine x will be x if and only if minus pi by 2 to pi by 2 is close. Otherwise, you can't write. Suppose you are writing sine inverse of sine 10. 10 is in radian. You cannot write this one equal to 10 because 10 doesn't satisfy this. Pi is 3.14. So 3.14 divided by 2, it will be 1 point something. 1.5 near about, and that side also 1.5 points. So it doesn't satisfy. You cannot write this. Can I write this graph now? I will move to the next one, cos. Actually, this understanding is the main part of the inverse. Relate. How will you relate? Lot of formulae you have in inverse. Lot of things you have. But how will you relate? That's the main important part of it. So let me go to the cos inverse cos x, right? Next is cos inverse cos x. So again, if you write y equal to cos inverse cos x, that will give you cos y equal to cos x. So that is equal to y is equal to 2n pi plus minus x, right? Okay, before that, let me write one formula for if you try to remember something in the previous case. Sine inverse of sine x. What I have drawn, just to make a compact form of that. Minus 2n pi plus x, and this is 2n plus 1 into pi minus x. So x belongs to 2n pi minus pi by 2 to 2n pi plus pi by 2, and x belongs to, in this case, 2n plus 1 into pi minus pi by 2 and 2n plus 1 into pi plus pi. This is the compact form of the sine inverse sine x. If you want to note down, please note down this one. what I have drawn on the graph and also the calculation, that is, this is the compact form. This is the compact form. Okay. So y equal to, now I have cos, right? So in this case, you have to remember that y should be within this range, 0 to pi. Y is inside this range. Okay. So if I draw the graphing, let's go to the graphing. Oh, this portion is not required. See, if you replace n equal to 0, it will be plus minus 6. So this is your y equal to x line, this is your y equal to minus 6. This is 5, this is minus 5. So for a particular value of n, you are getting two pairs of straight lines. First pair is y equal to plus minus, then you go here, it will have again two pairs. This is 2 pi, this is gonna be y equal to 2 pi minus x, y equal to x minus 2 pi. If you replace by 1, it will be 2 pi plus minus x. So this is 2 pi minus x. I think this side. Okay. This is your y equal to x plus 2 pi. And this side is your y equal to 2 pi minus x. So you have two pairs of solutions in this case. Just like you similarly sin x, if you are doing the calculation for sin x, in this case also if you can do the calculation for cos x, you have similar results. There is no negative, 0 to pi, y is confined between 0 to pi. So in this case also you have a very compact result. Cos inverse cos x, if you want to write in a very compact form, that is 2n pi plus x. X belongs to 2n pi into 2n plus 1 into pi. 2n pi plus x. X belongs to 2n minus 1 into pi into 2n pi. N belongs to the integers. This is the compact form. Whatever you have drawn. Okay. Next is tan inverse of tan x. So in this case you have y equal to n pi plus x. Right? But you have discontinuities at pi by 2, 3 pi by 2 like this. So how to draw the graph for tan inverse tan x? Let me draw the graph for this is your minus pi by, sorry, This is your minus pi by 2. This is your pi by 2. So this is your y equal to x. This is your pi. So this is your y equal to x minus pi. You have discontinuities at 3 pi by 2. Right? And this is your 2 pi. So y equal to x minus 2 pi. Y equal to x, y equal to x minus pi, y equal to x minus 2 pi, y equal to x minus 3 pi, y equal to x minus 4 pi, so on. And what about this portion? Y equal to x plus pi, y equal to x plus 2 pi, y equal to x plus 3 pi, and so on. These are the discontinuous. Clear? Okay? Got it? Then y equal to cot inverse of cot x. Let me draw. Y equal to x. Y equal to x minus pi. Because cot x has discontinuities are pi, 2 pi, 3 pi, etc. Undefined. 2 pi. Okay. This is your tan inverse of tan x, and this is your cot inverse of cot x. Now the graph of cosec inverse x cos x is very similar to sin inverse sin x. Only you have to exclude the points x equal to n pi. The graph of cosec inverse cos x is very similar to sin inverse sin x. Only you have to exclude from the graphs the points x equal to n pi. That means 0, pi, 2 pi, 3 pi, 5 pi, etc. Negative also. Just like you have excluded 0, pi, 2 pi in this graph, in cosec of cosec inverse x is also similar. And for sec inverse sec x, similar to cos inverse cos x, but you have to exclude. What are the points you have to exclude? For cosec of sec inverse sec x, 2n plus 1 into pi by 2. Odd multiples of pi by 2 you have to exclude to get the graphs of sec inverse sec x. Am I clear? Okay. Now let's have some problems on this. How to deal with the problems of trigonometry. Few problems. After that, I have few properties. After that, we move to more problems.
So cosec to 90
Now cosec pi. Let us have a problem. Suppose it is problem number 1. Find the value of tan inverse of tan 3 pi by 4. What is the value of tan inverse of tan 3 pi? Now you see, initially, first of all, you have to write tan inverse of tan x is x for x belongs to open bracket minus pi by 2 to pi by 2. Otherwise, no. So just I have drawn the graphs for tan inverse tan x. Once again, let me draw y equal to x. This is pi by 2, this is minus pi by 2. Okay? And you have y equal to x minus pi, right? Okay?
Ordered,
3 pi by 4 doesn't belongs to this, right? I'll answer your question. Wait. So you cannot write tan inverse tan 3 pi by 4 equal to 3 pi by 4, right? It is not equal to 3 pi because of this. So where is your 3 pi by 4? 3 pi by 4 would be here. Less than pi. So this should be the value of your function. So what is that? What is this graph? Tell me. So 3 pi by 4 belongs to, just write the interval where it belongs, pi by 2 to pi by. Am I clear from the graph? Okay. Now, what is your tan inverse tan x? What is your tan inverse tan x? It is not x. Because if it is lies between minus pi by 2 to pi by 2, you can take tan inverse tan x as x. But it is here. So what is the value of tan inverse tan x? X minus pi. What is your x? 3 pi by 4. It's minus pi by 4, right? Clear? Am I clear? So that is how you have to do, or you have to get a knowledge of the graph. You have to answer these questions. And tell me. I will go to the next problem. I will go to the next problem. Find the value of sine inverse sine 7 and sine inverse sine of minus 5. These are not, these are in radian. 7 minus 5, these are all in radian. So, first of all, how will you solve this one? First of all, first observation is that sine inverse sine 7 is not equal to 7, right? Because 7 doesn't belong to minus pi by 2 to pi by 2. That will be the reason. Yeah, you can write the close brackets for sine. But where is the value? Let me draw the sine curve. Okay, let me draw small. In your childhood, you might have drawn this type of mountains in your drawing copy. See the class 1 or KG copy, find out the class 1 or KG drawing copy. You will find mountains and the sun rises. Okay, 0, y equal to x. তখন তো আর ভাবনি যে এরকম ধরনের পর্বত গিয়ে লাস্টে ট্রিগোনোমেট্রিক ইনভার্স ট্রিগোনোমেট্রিক ফাংশন হয়ে যাবে। ছোটবেলার আঁকাটা কি কাজে লাগবে তখন তারা বুঝিনি। স্যাররা বলতো একটা পর্বত আঁকো সুন্দর করে, একটা সান পুরো একদম গ্লো হচ্ছে হলুদ কালার দিয়ে। এই ছবিটা মনে হয় সবাই আঁকে ছোটবেলায়। And what about this one? Minus, right? Again, I am drawing this because of for your understanding. Because for your understanding. So this is 0, this is minus pi, this is pi, this is 2 pi. Okay, this is your 5 pi by 2. Where is your 7? Can you locate 7 on the graph? Where is your position of 7? After? No, not after 5 pi by 2, between 2 pi and, because 2 pi 6.14 28. 3.14 into 2, that's going to be 6.28. So 6.28 and this is more than 7. So here, so 7 belongs to 2 pi and 5 pi by 2. 5 pi by 2. 2 pi and 5 pi by 2. So 2 pi and 5 pi by 2. Okay? So what is your sine inverse? Sine x in this case. What about sine inverse sine x in this case? It's going to be x minus 2 pi. Look at the graph. If you are between 3 pi by 2 and 5 pi by 2, your relation will be x minus 2 pi. Don't look at others. You have to look at the interval. So this is the graph. So therefore sine inverse sine x sine 7 is equal to 7 minus 2 pi. Am I clear? Is that clear? So draw the graph. If you have a question, draw the graph. This type of question and this type of question will come in the chain. And what about this sine inverse sine of minus 5? Where is your minus 5? This is your minus 5 by 2. This is your minus 3 pi by 2. This is your minus 2 pi. Where is minus 5? Here. Is it here? So sine inverse sine of minus 5, that is equal to, you have to consider this one, 2 pi plus x. So it's going to be 2 pi minus 5. Next problem. Find the value of cos inverse sine of minus 5. First observation is that it is a mixture of cos inverse and sine. And we are familiar with sine inverse sine, cos inverse cos, tan inverse tan. So first try to make this inside one, convert this part into cos. Because you have cos inverse outside, so in that case you need the diagram for cos inverse cos x. So I will write the given expression as minus sine phi, because sine of minus phi is minus sine phi, and you just remember cos inverse minus x, that is symmetric about the point 0 comma pi. I have written in property 1. So it will be pi minus cos inverse of sine phi. Am I correct? So all the things I am using, all the relations I am using. Okay, got it? Because cos inverse of minus x is pi minus cos inverse x. And correct? Now I will draw the diagram. Ah. Sorry. Yeah, correct. Whenever I solve a problem, I will draw the graph. So that the কোনটা এইটা pi by 2 cos pi by 2 minus theta মানে sin theta, complementary angles. So can you locate pi by 2 minus 5 of the graph on the x axis? Pi by 2 minus 5, because your alpha is actually pi by 2 minus 5. Can you locate that? Pi by 2 means 3.14 divided by 2. 1.6 suppose. So 1.6 minus 5. 3.4 minus 3.4. Where is your minus 3.4? In the year. Correct? So you will consider this one, right? So what happened? Your pi by 2 minus 5 is between this one. Now you will see in the books and also in the question paper, maybe some solutions of PDF or whatever you have downloaded from internet. The graph is not there. Only the calculation is there. And it is very difficult to understand how they are writing this. But in each and every problem, you have the graph of this. The explanation is very clear. You don't need this one. You just need the graph. That's it. Yes, I'm using this x plus 2 pi. What is your x? Your x is pi by 2 minus 5. But this is not your final answer because you have this one pi minus this. So I have written pi minus this. So this is a very good problem of J.
So the same can be signed outside also.
Okay, can I got this one? Now more properties. I will write the properties very quickly. Lot of properties you have because inverse trigonometry is basically the properties, and these properties are reciprocal. So you have cosec inverse x equal to sin inverse 1 by x mod x greater or equal to 1. You have sec inverse x cos inverse of 1 by x mod x greater or equal to 1. You have cot inverse x tan inverse 1 by x. X is more than 0. Pi plus tan inverse 1 by x if x is less than 0. Property 5. This relation, this one is the important one, huh? Because you have two cases. X more than x is positive, then you can write this one because this inverse relation will hold for x positive. But if x is negative, you have to write pi. Property 5, that is you have
Minus the
identity some having some identities basically on pi by 2, that is sin inverse x plus cos inverse x is equal to pi by 2 minus 1 less than equal to x less than equal to 1, tan inverse x plus cot inverse x equal to also pi by 2 if x belongs to R, and cosec inverse x plus sec inverse x equal to pi by 2 if mod x more than equal to 1. This can be proved. These are very simple. The complicated proof I will show you one proof. The next one. Can I note this one? The next part. So writing properties of inverse function and understanding the properties of inverse function, it will take 1.5 or more than that. So next identity or properties, property 6, that is basically the identities on inverse trigo. Number 1, sin inverse x plus sin inverse y is equal to sin inverse x into root over 1 minus y square plus y into root over 1 minus x square. X greater equal to 0, y greater equal to 0, and x square plus y square less than equal to 1. And this is equal to pi minus sin inverse x into root over 1 minus y square plus y into root over 1 minus x square. X greater equal to 0, y greater equal to 0, and x square plus y square greater than 1. You see a lot of complicated things are there. But you see the formula is very simple. What is the formula for sine of a plus b? Sine a cos b, cos a sine b, right? It's a compound angle formula. So you see sine a cos b, cos a sine b. Okay? So I will prove this one. Let me prove this one. Because why I am proving this one? Now, maybe sometimes the question will come in your mind that how this relation is really, or why there are so many restrictions on that, on the formula. Where somewhere greater than 0, why somewhere less than 0, why this is happening. So this type of questions can be answered from one identity I will prove, not the others. So let me prove this one. Let sine inverse x equal to a and sine inverse y equal to b. X comma y greater equal to 0. That means xy belongs to actually 0, 1. Positive. Okay. So a comma b belongs to 0 comma pi by 2, right? Which implies if your sine inverse x, that is xy belongs to 0, 1, then sine inverse x will be positive 0 to pi by 2. Both, if both of them 0 to pi by 2, then what happened to your a plus b? A plus b belongs to 0 to pi. Am I clear? Is it clear? Then you can write sine a plus b as what you can write? Sine a as x, sine a is x, cos b is actually you have sine b as y, so cos b will be root over 1 minus y square, and all are positive. Don't worry about the negative one. I am not considering the negative square root because all are positive, so square root will be positive. Am I clear? Am I clear? I am taking sine inverse on both the sides. Okay. Now, okay, let me write it. Now this equal to right. From the graph, I am writing this one. All are from the graph. Now you write your expression. You will get the result. So now, okay, let me write. Now a plus b less than equal to pi by 2. Then you have a less than equal to pi by 2 minus b, or you have sine a less than equal to cos b. So sine a less than equal to, what is your sine a? X. What is your cos b? Minus root over 1 minus y square, right? So you have x square plus y square less than equal to 1. Tell me, is that clear? So why the relation is there? X square plus y square less than equal to 1? Because of this relation. So you can write sine inverse x root over 1 minus y square, y root over 1 minus x square equal to sin inverse x plus sin inverse y x square plus y square less than equal to 1, x comma y greater than equal to 0, and pi minus sin inverse of x root over 1 minus y square plus y root over 1 minus x square plus y square less than 1. Okay? Proved property in this article, if you write number 2, I am not showing all proof now, I will write the properties and will step move to the problems. This is like sin A minus B formula. Sin A cos B minus cos A sin B. So sin inverse x root over 1 minus y square minus y root over 1 minus x square. Okay? X, y belongs to 0, 1, like the previous one. Cos inverse x plus cos inverse y. What is the formula for cos A plus B? Cos A cos B minus sin A sin B. So cos inverse xy minus root over 1 minus x square into root 1 minus 1. X comma y is equal to 0. Number 4, cos inverse x minus cos inverse y is equal to, you have two parts in this case, plus, right? X less than equal to y. Yeah. The previous one, first one is x less than equal to y or equal, x less than or equal, and in this case you have x greater than y, you have to use this one. So you have to check somewhere in JEE problem these conditions. Actually, people will start here and here. No. I'm not giving you the proofs of all this. Proof is similar to this. Okay? I will show you. You can try this proof. If you can't, I will give you. No pi. Here you have pi. But not here. And look at that, plus have only one formula. But minus you have two. Now last property or identities. Tan. That is on the tan.
Sorry, প্রুফটা করেছিলেন আপনারা
ছিল আচ্ছা that is screen sharing, right? Is that helpful? All my lectures helpful?
ওখান থেকে তো দেখে পড়ছি
Okay. Huh? Yes. Thursday live stream, I think. That I was testing actually. Next day, we have a seminar at our college. Yeah, this is the formula. Tan A plus B is tan A plus tan B by 1 minus tan A tan B. And this is applicable only if xy less than 1. The product must be less than 1. But if the product is more than 1, what will happen? It will be pi plus tan inverse of x plus y 1 minus xy, x comma y greater than 0, and xy is more than 1. And minus pi plus tan inverse if x comma y less than 0 and xy more than 1. If it is positive and more than 1, if it is negative and more than 1, and if it is positive and less than 1, only this. So this relation will be valid if and only if xy less than 1. Otherwise, you cannot use. And the last one, last but not the least. So this is very useful also. Okay. So see how much time have taken to writing the properties, drawing the graphs, understanding the problems with the graphs. আমি কিন্তু সব প্রবলেম প্রপার্টিজ গুলো প্রমাণ করলাম না, তাতে বাজে টাইম লেগে যাবে। আমি যদি প্রত্যেকটা প্রপার্টি ধরে ধরে এইগুলো সব প্রত্যেকটা প্রমাণ করতে যেতাম, so it will take a lot of time. But you have understood somewhere so what is the connectivity. While writing these conditions, restrictions of the inequations, that you have understood. Now I will do some problems on. Okay, problem. Problem number 4, I guess. The value of, today we have some simple problems. Next day we'll have more advanced problem. Maybe it will take, next day it will take 1.5 hour or 1 hour more advanced. Because today more time is consumed in the theoretical. Sin inverse, cot, sin inverse 2 minus root 3 by 4 plus cos inverse root 12 by 4 plus sec inverse root 2 is 0, pi over 2, pi over 3, and the last option is none of this. Let me write example 5 also simultaneously. The value of cos inverse root 2 by 3, cos inverse root 6 plus 1 over 2, 3 is equal to pi by 3, pi by 4, pi by 2, and pi by 6. What is option for the first one?
স্যার ফার্স্টেরটা অপশন এ হবে।
Option A, it is 0, right?
হ্যাঁ স্যার এ হবে।
Okay. Can you explain, Ishan? Sin inverse cot. What about the angles? What about sin inverse this one? 15 degree. 12. Pi by 12.
Yes, 15.
Pi by 12. Okay. What about the next one?
And by
Is it clear? So that will be equal to
2/3.
yes,
Inverse cot
cot pi by 2.
2/3.
Huh? Pi by 6, I think. This is pi by 6. Now you calculate. Pi by 2. So 0. Actually, cot pi by 2 is 0. So sin inverse 0 is 0. So your option. Go to the next one.
স্যার পাই বাই 6।
Pi by
6।
yes, pi by 6. Explain, Ishan. It's better to move this cos inverse all this to tan. Tan's formula is very simple.
স্যার ট্যান আর কটে তাহলে করা যাবে ব্যাপারটা।
So what is your cos inverse? Cos inverse root 2 by 3 equal to theta. So cos theta is root 2 by 3. So what is your tan? Or you can write sec square from here. Sec square will be 3 by 2, right? So So tan square theta is basically sec square theta minus 1. So it is a half. So tan theta is 1 by root 2. So theta is tan inverse 1 by root 2. Got it? So you see your cos inverse converted into tan inverse. Because tan's formula is very simple. Tan of a plus b. Rather than cos and sin. Because x root over 1 minus y square, y root over x minus is a very complicated formula for sin and cos. So this will be this will be transformed to, this will be transformed to tan inverse 1 by root 2. And what about this one? If you convert this into tan, what is your tan inverse? I think it will be, just check, huh? Please check if this is converted into tan. Similarly, cos theta is equal to this, then you write sec theta, from sec theta you write sec square theta, then write tan square. Tan square theta is equal to sec square theta minus 1. You will get this. So this is nothing but your, you see, tan inverse x minus y by 1 plus xy. If you take the product of this, it will be this, root 6. So this is equal to tan inverse 1 by root 2 minus tan inverse root 3 plus tan inverse root 2, right? And tan inverse root 2 is cot inverse 1 by root 2. Check the properties. So this is going to be pi by 2. Pi by 2 minus tan inverse root 3. And what is your tan inverse root 3? Pi by 6. So pi by 2 minus pi by 6. Pi by 3. Root 3 is pi by 3. So pi by 2 minus pi by 3. So the thing is that how quick you are applying the properties and quickly get the solution. That is the main thing. You could have done it in a different way, but it will take a lot of steps to calculate. Very quickly you have to calculate and using the properties. You could have taken cos inverse formula also. Where? This is clear? Where? Okay.
So even cos inverse x minus cos inverse y. Cos inverse x minus cos inverse y by x square.
Solve is very complicated. You try at home, but it will take few steps. See, 10. My suggestion is whatever be the things, convert into 10, and try to remember the properties of tan inverse. Last one, tan inverse x plus tan inverse y, tan inverse x minus tan inverse y. If sin inverse alpha plus sin inverse beta plus sin inverse gamma equal to 3 pi by 2, then alpha beta, beta gamma, gamma alpha is option A 1. This is easy. 0, 3, minus 3. Seven, 6 square, tan inverse 2 plus cosec square, 40 inverse 3 equal to 5, 13, 15, 6. What about the first one? Yes, it's very simple. Look at that. Sin inverse alpha plus sin inverse beta plus sin inverse gamma is 3 pi by 2. What is the range of sin inverse alpha? Or what is the maximum value of alpha? This is possible if this relation will be possible if sin inverse alpha is pi by 2, sin inverse beta is pi by 2, and sin inverse gamma is pi by 2. Otherwise, you cannot have 3 pi by 2, right? So sin inverse alpha is pi by 2 means alpha is 1, right? This is possible. This relation holds if and only sin inverse alpha is pi by 2, sin inverse beta is pi by 2, sin inverse gamma is pi by 2. Otherwise not. So that implies alpha equal to beta, gamma equal to 1. So what would be the product? 3. Tricky one. Next. You try the next one. I will write the next question, example 8. That is tan of pi by 4 plus half cos inverse x plus tan of pi by 4 minus half cos inverse x not equal to 0 is equal to x 2x 2 by x, none of this. What you are thinking about? Let us assume tan inverse 2 as alpha. So your tan alpha is 2. So this is your sec square alpha. What is your sec square alpha? 1 plus tan square alpha. That is equal to 5. Similarly, assume 14 verse 3 as beta. So cot beta will be 3. So cosec square beta will be 1 plus cot square beta. What is that? 10. So 5 plus 10, 15. Okay, clear? Bujha geche? Understood? What is your option? This is the last question, please. So next class we'll have more advanced problem on inverse. Maybe 15 to 20 advanced problems on inverse. Today we have very easy problems on JEE mains. Next class will be on more complicated problems from mains and advanced. So you can write tan A plus B, right? Tan pi by 4, your expression. This expression will be tan of half cos inverse x by 1 plus 1 minus, right? Plus 1 minus tan of half cos inverse x by 1 plus. Okay. Then you have 1 plus tan half cos inverse x whole square plus 1 minus tan half cos inverse x whole square by 1 minus tan square half cos inverse x. A plus b whole square plus a minus b whole square, that is equal to 2 into a square plus b square. Okay, so that is equal to 2 pi 1 minus, okay, the formula is cos theta cos 2 theta equal to 1 minus tan square theta over 1 plus tan square theta. So this is equal to cos of 2 half cos inverse x, right? That is cos of cos inverse x. and x not equal to 0. So 2 pi x. Okay. Okay. Thank you all of you.